Alright. This section right here, basically what's happening in this section is that we're doing a rotation. So when you rotate, you need to know the angle that you're rotating on, and you need to know the point of rotation. So if you notice here, we're using a lowercase r. Again, you have to know the angle, and you have to know the angle of rotation. Basically what happens, so this right here is the original image. When we rotate it, the angle between these two is whatever that angle of rotation is, and then these segments have to be congruent. So I'm going to show you down here doing this one. So in this one I am rotating 50 degrees around that point C there. So when I rotate that 50 degrees, basically what I'm going to do here is I'm going to start and see, so this is about like 2.1, this distance right here. So when I make that new O, I want it also to be 2.1 from C, but then I want the angle in here to be 50 degrees. If I don't really have like, I didn't give you a protractor or anything like that, but basically, I mean, if I went right here, that would be a 90-degree angle, and so 45 is half of 90, so 50 is a little bit more than that. So if this was 90, maybe that's 45, so if I go a little bit more, again, we're just kind of guessing here, but I want to make that distance right there the same, so I want to make that 2.1, okay? So then this would be my O prime. So again, this angle in here is my 50-degree angle. So I would do the same thing for L. So if you notice here, I'm going out to about 3.3. And again, if I was here, I'd be like at 90, but I don't want to be at 90, so I want half of that. So maybe I'm about it here. So again, we're going to go 3.3. So this would be that L prime. Again, I know we're not doing it perfectly, and again, this angle in here is now 50 degrees. Lastly, when I go to B, so if I go to B, I'm like at 3.6. Oops, I went a little bit beyond it. So then a 90-degree angle, but I don't want 90, so maybe like 50 is like here. So again, I'm going to 3.6. I know this isn't perfect. Here's B prime. Again, this angle in here is 50. Obviously that 50 is a little bit bigger than my other 50s, and then I would connect these, okay? So I kept these distances the same from that point C, and then the angle in between those lines that I just marked are always 50 degrees, or whatever your angle of rotation is. Okay. When we do these in the coordinate plane, we are always going to rotate around the origin. We're also always going to be going counterclockwise. So all your rotations will always go counterclockwise in that direction. Clockwise is this way, counterclockwise is that way, okay? So we're going counterclockwise. This one is the easiest one to look at. This is a 360-degree rotation about the origin. So with this one, whatever the point is, when I rotate 360 degrees, I'm back at the point. So you can see here, in this one, XY, it's just XY. This one right here, when I do a 180-degree rotation, so the angle right there is 180, what's happening here is that your x-coordinate is becoming negative and your y-coordinate is becoming negative. Even if I were over here and I would do a 180 rotation, that rule would still apply, okay? In this one, you're moving 4 quadrants, so you're going all the way around. This one, you're moving 2 quadrants. This one right here, what happens here, so in this one, when you do a 90-degree rotation, you're only moving 1 quadrant away. So in this 90-degree rotation here, so if I had 2, 3, I'm going to come over here. So what happens is your x becomes your y, and your y becomes your x, but the sign is changed. If I didn't change the sign, well, I'm sorry, if I didn't flip the points, so let's say I would have done 2, like -2, 3, there's no way that this would have formed that 90-degree angle. So the reason why I want to switch the sign and switch the points there is so I make that 90-degree angle, okay? This one you're just going to have to like memorize that. This one right here, when we do 270, we're moving 3 quadrants. And when we do 3 quadrants, what you notice here is that the x becomes the y and it's negative, and the y becomes the x. Again, they don't always have to start here. This rule just works no matter where they are. So if we look at this example back here, this example right here, it looks like we're doing a 270-degree rotation of this figure about the origin. So if I go back over here, the 270 says that my xy goes to y negative x. So what I would do here, so these new points, so f prime, so if I go here, my x, so this is negative 3, becomes my y, but I have to change the sign, and my y becomes my x. My g prime, my x, becomes my y, but I change the sign, and this becomes, my y becomes my x. H prime, my x becomes my y, but I change the sign, and my y becomes my x. I prime, my x becomes my y, and I mean negative 0 doesn't make any sense, and then my y becomes my x. So those are my new points. So then over here, I would graph them. You can have overlap with these rotations. And there it is. Okay, so that is that for this section.